Okay, today we're doing similar triangles. Now we need to actually explore what similar triangles actually are. So what we have here is we have a triangle and we're just going to copy it. And if we copy it, we will notice that the two triangles, they actually match each other perfectly. Now when they match each other perfectly, that's called congruent triangles. So when one triangle fits over the other, it means they're congruent, they're identical triangles. Now, a common mistake is that someone says, well, oh yeah, congruent triangles, they have the same angles, therefore they are congruent. And that is wrong. If triangles are congruent, they do have the same angles. But if two triangles have the same angles, they are not necessarily congruent. So what I'm going to do here is I'm going to enlarge this triangle, and what we're going to look at is clearly not congruent because they don't fit each other. But let's have a look at the angle. The angle here is the same. The angle here, the same angle. And the third angle is identical. So we do have a formula for similar triangles. If two triangles are similar, then it means the angles on one triangle will match the angles in the other triangle. So, and that is actually very, very important. So I want you to copy down the following notes immediately. So the first thing is I want you to put a title in, which is quite simply Similar Triangles. So similar triangles. And there's a rule for similar triangles. And the rule for similar triangles is if two triangles are similar, then the angles in one triangle will match the angles in the other. If two triangles are similar, then the angles are the same. But the other aspect of it is, which is equally as important, if the triangles are the same, if the triangles have the same angles, then they are also similar. So it's true both ways round. So we've got what's called a converse of a statement. If the angles of two triangles are the same, match, if you like, then the triangles are said to be similar. Okay, so let's take these two triangles. We know that this angle here is identical to that one there because we just tested it. We know that the angle at the top corner here, I'm using 3 lines, matches this angle here because we tested it. And then this final angle down the bottom, we know is also going to be the same angle because we tested it. And because we know that all the angles in one triangle match all the angles in the other triangle, then these two triangles are said to be similar. Now, this is the important bit. What does that mean? How can we use it? What's special about this? Well, similar is another word for one is an enlargement of the other. So what I'm going to look at now is I'm going to label these triangles A and B. So this is triangle A and this is triangle B. This triangle here has got length A, B and C. And this triangle, just to mix it up, is X, Y and Z. And we know that they're similar triangles then because they have the matching angles. But similar triangles have a special property. And in order to identify that special property quickly, we draw a table. So what I'm going to do now is I'm going to draw a table for triangle A and triangle B. And I'm going to draw this as neatly as I possibly can. So I'm going to put a line down the middle. Want this to be as neat as possible. Just line across there. And I'm just going to pick the letter A off triangle capital A. What does that correspond with? What does that match up with on the second triangle? Well, I'm going to do all the talking today, so I apologize for that. So I look at where A is, and A is in between the angle with 2 lines on it and the angle with 3 lines on it. So I go over to this triangle and I look for the symbols which match up with 2 and 3, and the length that matches up is the length Z. So I know that A corresponds with the length Z. I'm now looking at the B on the first triangle, and that's in between the single curve marking an angle and the triple curve. And there's on the other triangle, there's a single, there's the triple. Because of the way I've drawn it, they happen to be in the same place positionally. So if you spot that, it can make it even easier. So B corresponds with Y. And then, of course, last but not least, then C is going to correspond with X. Why is C corresponding with X? Because it's in between the double to single, and X is in between the double to single. Now, there's a theorem on your course which you do not have to prove. In fact, the proof of that theorem doesn't present itself to you until you get to your Leaving Cert year. And the theorem actually states that if you divide A by Z, then that's going to be equal to B divided by Y. So what you're doing is you are reading across the table. A divided by Z is going to be the same as B divided by Y, and it will also give the same answer as C divided by X. And that is basically the introduction and the finish of similar triangles. Now, what I'm going to do now, I'm going to have a quick look, is we're going to go straight on to the example. Okay. First of all, you're presented with 2 triangles in the exam. You're told that the purple coloured angle matches identically the purple coloured angle in the other triangle. You're told that the green matches the green. So we now know that this angle here, because it's the third angle in a triangle, must match this angle over there. And the question quite clearly states, find the value of P and Q in the diagrams below. So how do you know they're similar triangles? Well, you know they're similar triangles because all 3 angles in one picture matches all 3 angles in the other. What do similar triangles mean? Similar triangles mean that one is an enlargement of the other. How do we solve problems involving similar triangles? We draw a table. Now, if you're going to draw a table of results, then you need to be neat about it. So I'm just going to draw a table here to try and be neat about it. And make the picture just a little bit bigger for you. And I'm going to be terribly sophisticated in this. I'm going to call the triangle on the left, left. I'm going to call the triangle on the right, right. I could say the triangle on the left is smaller, couldn't I? So I could go with small and large. It doesn't matter. What the hell? I think I'll go with small and large. So the triangle on the left is going to be called small. And the triangle on the right is going to be called large. And I'm just going to pick a length at random on the left-hand side. And for the sake of argument, I'm going to pick P. Now, what I want you to tell me is by a show of hands, is I want to find the corresponding side to P. I need to write in here the corresponding side. And I'm using a visual approach, which I won't say just yet. And I want a show of hands. I want what is the corresponding length. We've got 3 lengths on the second triangle, Q, 10 and 8. And I want to know which one is the corresponding side. So show of hands. Who thinks it's 10? Well, no one. It's very good. We're moving across the page. So the next letter we come across is the letter Q. And who thinks it's Q? And no one. So who thinks it's 8? And I'm assuming you think it's 8 because where's P? P's between the purple, the red, I'm a bit colourblind, could be brown, and the snowflake and the star. And where's 8 between? It's between the same 2 angles. And that's how you work out what the corresponding sides actually are. So you now know that this thing here corresponds with 8. So again, going back to the first triangle, the small triangle, I'm going to focus now on 14. I'm going to focus on 14 and I'm going to write it down. And what I've got to do now in the second column is pick out the corresponding side for 14. So I'm going to go across from left to right. Who thinks it's 10? Okay, that's pretty good. Why is it 10? It's going to be a rhetorical question because I'm taping for another class. I apologise for that. So why is it going to be 10? I'll cut the rhetorical bit out. I have to cut it out again now. So why is it going to be 10? Well, let's look at number 14. The number 14 is a length. It's in between the purple and the green. It has to correspond to a length on the other triangle in between the same 2 angles. And the same 2 angles, the ones that match the purple is this one, and there's the green. So therefore 14 is in between purple and green. It's in between purple and green. So 14 corresponds with 10. And then what have we got left? We've done the P, we've done the 14, 21. 21 is in between the star and the angle marked with a green colour. So the one over here, which is in between a star and the green colour, is Q. So star in green colour on the small one is 21. And the star and the green colour on the large one is Q. So we've got the corresponding sides. We now create a fraction. I'm looking for P. They told me to find P. What am I allowed to do with the P? I'm allowed to divide it by 8. I'm allowed to divide it by its corresponding side. So now I need to pick a pair where I've got numbers involved, and it's going to be 14 and it's going to be 10. Now, which one did I divide first? It was P divided by 8, wasn't it? So it's hands up time. Is it 14 divided by 10? Or is it 10 divided by 14? We know it's going to be division, but which way round? Who thinks it's 14 divided by 10? You're correct, because that's the way we had written the first one. It's the small divided by the large. So therefore, small divided by large is 14 over 10. Now, this is when it gets silly, because what you're doing there is a theorem which you don't have to prove until you're in Leaving Cert. The knowledge of it you have to have for junior cycle and all the way through 5th year and all the way through 6th year. And when you finish drawing a table and applying it, where are you? You're back in 2nd year. Because you're looking for P, and that means you have to get rid of a divide by 8. How do you get rid of a divide by 8? Well, in order to get rid of a divide by 8, you are going to be multiplying by 8. So you end up with 8P over 8 is equal to 8 times 14 over 10. The 8's cancel, so P is now equal to 8 lots of 14 over 10. And for speed in an examination situation, what you're going to do now is you're going to tap it all into a calculator. So 8 times 14 divided by 10, and the answer is 56 over 5, which is a fairly acceptable answer, but you'll probably check to see whether a decimal version is neat. So 11.2, I think that's neat enough. There's no recurring decimals, so we'll leave it at that. Now, the second part of the question was finding Q. And this is where it's clever. Because what I'm going to do now is, because I'm looking for Q, instead of doing 21 divided by Q, I'm going to do Q divided by 21. So you stay focused, because what am I now doing? I'm now doing large divided by small. So what's it going to be equal to? Is it going to be equal to 14 divided by 10? Or is it going to be equal to 10 divided by 14? So hands up now, please. Who thinks it's 14 divided by 10? Well, no one. That's excellent. What about 10 divided by 14? Well, it's the only other choice. And of course, the reason why is because you were focused on the fact that Q is on top. So if Q is on the top of the fraction, then 10 has to be on top of the fraction. So it's 10 divided by 14. And then, once again, we're back to 2nd year mathematics, where I have to get rid of the divide by 21. How do I get rid of a divide by 21? Well, I multiply everything by 21. So I end up with this. The 21 cancels. So you end up with Q is equal to 21 times 10 divided by 14, which I think comes to 15. I've actually cancelled it out. What's special about 21 over 14? Well, it's 3 over 2. So if I use the cancelling out method, 7s go into 14 twice, 7s go into 21 3 times. 3 10s are 30. 30 divided by 2 is 15. I could also have done 2s into 2 go once, 2s into 10 go 5, and the answer is 3 lots of 5 is equal to 15. And that's the end of that particular problem. And the exercise is exercise 26.1, and it's numbers 2 to 8. Now, before we go on to do that, Okay. Let's have a look at example 2. Now, the only thing that's confused me about example 2 is why is it halfway down the page? So let's just push it up to here, and we'll actually just quickly do this. Now this is proof. People don't like proof questions because they actually don't realise how simple they are. So the first thing is, what am I trying to prove? I'm trying to prove that the triangle ABC is similar to the triangle AXY. That's what I am trying to prove. So the first thing is, what have we been given? So we're doing a proof. The first thing is to take note, what did they tell us in the question? What did they tell us in the question? What information did they give? What's been given? So what's been given? Two triangles. What are the two triangles? ABC and AXY. What do we know about these two triangles? One is superimposed on top of the other. What else do we know? We know that the line XY is parallel to the line BC. So what have we been given? We've been given two triangles. And what are those two triangles? Triangle ABC and triangle AXY. What else were we given? We were given that XY is parallel to BC. Okay. What have we been asked to prove? What do we need to prove? So once we've done the given, we actually focus on what we need to prove. And what we need to prove is that the two triangles, triangle ABC, is similar to triangle AXY. And the formula for similar is that all three angles in one triangle have to equal the three angles in the other triangle. So we need to show that all the angles in one triangle equal all the angles in the other. Now, you don't have to do this, but when you're in an exam situation, it's actually quite a good idea. In fact, it's an excellent idea to highlight the two triangles that you are going to be focusing on. So I'm going to highlight the big one by putting round it a purple line. And then the smaller triangle, I'm going to highlight it by putting in a blue line, just to make it stand out. And I'm not going to separate out the triangles. I'm going to leave one superimposed on top of the other. I am now going to put in numbers. I'm going to put in here 1, 2, 3, 4, and 5. What do I know about angle 2 and angle 4? They're equal. So we know that angle 2 is equal to angle 4. Can anyone remember the technical term for those two angles? There's a non-technical term which is just as good. We did it a couple of weeks back. What's those two angles called? You can use letters. The letters were Z, F, or C. So what I want you to do now is, if they were a Z angle, they're equal. If they're an F angle, they're equal. If they're a C angle, they add up to 180. They're not equal. So hands up. I'll go through it go through it alphabetically. So what was it? C, F, and Z. So you've already said to me that 2 and 4 are equal. So it can't be a C angle, because a C angle, they're not equal. They add up to 180. Next letter in the alphabet. Is it an F angle? Hands up if you think it's an F angle. It is. Because an F angle is you find two parallel lines and you then draw a line cutting through it. And these two angles here are equal. If you like it, that looks like an F the wrong way round. So that's an F angle. But an F angle can occur in lots of different places. These two angles are equal. And again, the shape in this time is a proper F. So a Z angle is when it goes like this. Just a quick reminder, a Z angle is when it goes like that and over there. And those two angles are equal, but they're called Z angles. Now, does anyone remember what an F angle, its official name is? Which is really irritating because it actually begins with C. Yeah? Corresponding. So what we have here is, why are they equal? Because they are F angles, and the technical term for an F angle is corresponding. Now, can someone please tell me what's special about the angle 3 and the angle 5? We already know what's special about it. We're just looking at it. It's obvious. They're equal, and they are F angles again, and therefore they are corresponding. The only thing that makes something a proof is when you give a reason. So if I said angle 3 was equal to angle 5 and didn't back it up with an argument, it's not a proof. So basically, you know it's an F angle, you write it down, it becomes a proof statement. So it's an F angle, and once again, it's corresponding. Now, the ABC and the AXY, what do we know about angle 1? Yes, it's in both triangles. So angle 1 is equal to angle 1. There's 3 reasons for this. You could argue it's the third angle in the triangle, but the most common way of arguing it is it's common to both pictures. It's a common angle. Do we have 3 angles in one triangle equal to 3 angles in the other? Yes. Now, 2, 3, and 1 is making reference to triangle AXY, and this is making reference to A, B, and C. So triangle ABC, comma AXY, comma triangle ABC are similar because all 3 angles in one match the 3 angles in the other. So we've now proved it. That's the proof bit done. Now it's going to be on a video, so you'll be able to watch it later. How much is the proof worth? It's worth 10 marks. What do you get marks for? You get marks for writing down what they gave you in the question. So if you can actually read what they gave you in the question, you're going to get marks. You get marks for writing down need to prove. So they told you to prove it was similar. So what do you need to do? I need to prove it's similar. But really, that's not good enough. What's the formula for similar triangles? 3 angles in one triangle match 3 angles in the other. So basically, need to prove that so I should have put in here, i.e., 3 angles in triangle AXY need to match 3 angles in triangle ABC. And of course, what I did then is I went on to do it. Now, if I'd left this bit out, which I did, apologies for that, but I still went on to do the work, they will give me credit for it. But if I mucked up doing the working out on the right-hand side and forgotten to write that bit of writing on the left-hand side in, then I might lose more marks. So that's basically it. And now we finished. Now what bothers me about people in exams is they see a proof question, they panic, they don't do it, and they leave the rest of the question. And that's just silly. So what we're going to do now is we're going to reset the page. So give it all the way back to the way it was. And we know they are similar triangles because they told us. We don't have to go through the proof. But what I'm going to do now is I'm going to use what we did earlier on. I'm going to put up in here, I'm just going to put a dot, a red dot. In here, I'm going to put a snowflake, asterisk, and I'm going to put an asterisk down there to indicate the corresponding angles. On the other side, I need another code. So the code I'm going to put here is going to be a single curve and a single curve. You get marks for putting stuff, anything correct at all. So here it says AX is equal to 6. So AX is equal to 6. There's AX. So AX is equal to 6. It says BC is equal to 6. So this length down the bottom is also equal to 6. AY is equal to 5.5. So AY is equal to 5.5. And it says AB is equal to 9. And it's asking us to find YC. So where's YC? YC is down here, and I've decided to call YC X. And it asks me also to find XY, and XY is this line here, and I'm calling it Y. I might get marks for that. But what's the method for similar triangles? You draw a table. You make it fairly obvious what is what. So I'm going to draw a table. And I'm going to use the expression large and small triangle just to make my life just a little bit easier. So which one's the small triangle? It's AXY, isn't it? So I'm going to put up here the small triangle AXY, and that's the small triangle. Over here, my focus is on the large triangle, and the large triangle is ABC. Now, I'm going to pick a length off the small triangle, and I'm going to pick 6. I'm going to pick 6. What does that correspond to? Well, on the small triangle, it's red dot to snowflake. So red dot to snowflake on the large triangle corresponds to the number 9. So therefore, I've got 9. Now I'm going to go to the small triangle again. I'm going to look at Y. On the small triangle, what does Y correspond to? Anyone? Well, Y is in between the snowflake, the asterisk, and the single curve. So on the large triangle, what's in between the asterisk and the single curve? 6. In between the asterisk and the single curve is 6. Now, this is where people make mistakes. On the small triangle, between the dot and the single curve, I've got 5.5. What have I got on the large triangle? Yes, it's 5, between the small dot and the single triangle, I've got 5.5 plus x. So I've got 5.5 plus x. Now, I want to find the y. What's the rule if I focus on the y? The rule is if I focus on the y, there's no choice. I have to divide by 6. I have to divide by 6. So it's y divided by 6 is equal to, anyone? What's the only one that would give me an answer? 6 over 9. So y divided by 6 is going to be equal to 6 over 9. This is how the similar triangles work. What I want to do is I want to get y on its own, which means I need to multiply both sides by 6 to get rid of the divide by 6. So I end up with 6y over 6 is equal to 6 times 6 over 9. The 6's cancel. Y is equal to 36 divided by 9. The answer is 4. It's 4 centimetres. I am now looking for the x. So can anyone want to volunteer? What's that going to be? What am I going to form equation-wise? Anyone? Absolutely. It's 5.5 plus x over 5.5. And what's that going to be equal to? It is, because what we did was we did large now divided by the small. So we must always remember that when we're comparing similar triangles, we must do the division the same way round. So because we did large divided by the small, we've now got to do 9, the larger number, divided by the 6. What do I multiply both sides by? 5.5. So get a pencil out, put the brackets round, put 5.5 here, and now we're going to have 5.5 on, let's do that in black, 5.5 on 5.5 plus x over 5.5 is equal to 5.5 on 9 over 6. 5.5 cancels, so 5.5 plus x, definitely a reach for calculator time. So 5.5 times 9 divided by 6 is equal to 33 over 4, which is there a neat version for that? Yes, it is, 8.25. So 5.5 plus x is equal to 8.25. What do I have to do now? What happens to the 5.5? Switches sides, becomes minus 5.5. So x is equal to 8.25 minus 5.5. So x is equal to 11 over 4, or 2.75 centimetres. And technically speaking, you should finish off with the question. So they asked you to work out YC. YC we called x, and x is 2.75 centimetres. And then for part 2, they asked you to work out xy. Xy was labelled y, which we calculated has been equal to 4 centimetres. And that is the end of the